Hey guys, I'm going to cover concentration from the PowerPoint presentation that I posted. I like starting off with this graphic, okay? And then I'm going to go over this with my pen. So what's the difference between this circle and this circle? What do you notice is happening in each of those circles? Okay? What you notice is there's a lot more people in this area than this area. Okay, we would say that this area right here is more concentrated with people. Okay, this is the same idea with any concentrated solution. That's what it means to be concentrated. There's more stuff, there's more solute in a particular solution or in a particular area. All right, let's move on. Okay, so this first slide is just kind of a definition slide. What is concentration? It's a measure of how much solute is dissolved in a specific amount of solvent or solution. And then what's a concentrated solution? Well, a concentrated solution contains a large amount of dissolved solute versus a dilute solution that contains a small amount of dissolved solute. Okay, and I really like this graphic right here. Let me change from yellow, I guess. Let's kind of go back to red. This graphic right here. So this is kind of a look at the molecular level. So let's say we had two solutions of equal volume. In the dilute solution, you would not see as many of these dots. Well, what do those dots represent? Those dots represent the dissolved solute. So as you can see, there's more dots on the right side. Okay, that's because that solution is more concentrated. So if you have more dissolved solute, more concentrated. All right. Okay, easy enough, right? Okay. Now, this little checking for understanding, I didn't have the answer here because I couldn't fit it. So I'm going to go over it right now. So this says that, okay, let's say we had a solution of, let's call it table salt and in water. Okay, table salt and H2O. Let's say we had that, and then we added even more salt. What are we doing to that solution? Are we making it more dilute? Are we making it more concentrated? What are we doing to it? And if you said we are making it more concentrated, you would be correct. Okay, if we add more solute and it dissolves, we're making it more concentrated. Okay, moving on. Now, this slide is just kind of a checking for understanding slide with a couple questions to help you understand the difference between something that's qualitative and something that's quantitative. I know we've talked about this multiple times. This could be in terms of research and lab and data collection, but we've definitely covered those two terms. So let's tie it into concentration. Okay. The first thing is taking a look at the two iced teas. I believe they're iced teas. Yeah, iced teas. Okay. Just by looking at them, qualitatively, could you describe these two solutions to me? And you can. If you notice, the left one is a bit darker than the right one. What can be said then? Okay, you could say that the one on the left is more concentrated than the one on the right. That's because it appears darker. If it appears darker, we can kind of infer that there's more dissolved solute in there. All right. So qualitatively describing this situation would be the darker cup of tea is more concentrated than the lighter cup. Okay, qualitative. Okay, qualitative is purely an observation. Okay, let's move on to the next one. All right. This one asks, identify the most dilute of sugar beverages. Explain how you know this. Now, this chart, let's zoom in a little bit so you guys can see it. Okay, so on our y-axis, we have grams of sugar. And on our x-axis, we have the different types of sodas. Okay, now, the most dilute, right? We're looking for the most dilute. Yeah, the most dilute of the beverages. Well, what would we be looking for here in this particular graph? Well, our grams of sugar, that's our solute. Okay, the more solute that's dissolved, guess what? The more concentrated it is with sugar. So we take a look at the graph. This Ball's Geek beer, this is some type of root beer. This would actually be most concentrated with sugar. Okay, the least would be A&W cream soda. Okay, so most concentrated, Ball's Geek beer. Least concentrated or most dilute would be A&W cream soda. So if we're looking for the most dilute, that would be the A&W cream soda. The most concentrated would be the BAWLS Geek beer. Okay. All right, so quantitative is something that's measured. Okay, we're taking a look at some data. We're looking at the numbers. Okay, the Geek beer is at 72 grams versus the A&W cream soda, which is at around what 61ish grams. So how there's there's values, and we're comparing the values. That's quantitative. Anything that can be measured is quantitative. Okay, so hopefully that makes sense. All right, now some more formulas for you, but they're easy. Trust me. Excuse me. All right, so qualitatively, there's a couple ways to describe it, right? Observation, like for example, this drink is heavily concentrated. Notice how we're not like comparing statistics. We're not measuring something. Okay. Quantitative, this drink contains 15% juice, right? That's something that can be measured. All right. Okay. What are some ways to quantitatively describe concentration? Now, the first one you did in your guys' simulation was molarity. Okay, I'm going to give you a couple more. Okay, there's percent and ppm. Now, there's percent by mass and percent by volume. Okay, percent by mass is a solid in a liquid. Percent by volume is a liquid in a liquid. Okay, but they're the same exact calculation. The same exact calculation. So, percent by mass or percent by volume. You're taking the mass of the solute and dividing it by the mass of the entire solution, then just multiplying by 100. So it's just a piece over a whole times 100. That's it. And you're getting a percentage. Okay. All right. Let's take this. If something is 15% juice, then it's 15 per 100 parts. Okay? 15 divided by 100 is 0.15 times 100 would be 15%. Okay? Basically, all percentages is parts per 100. That's it. Okay? Then over here, our next one is ppm. That's parts per a million. Parts per 1 million. Notice how it's the same exact calculation as previous. It's just the mass of the solute over the mass of the solution. Okay? Same exact. Now, instead of multiplying by 100, we're multiplying by a million. Okay? So rather it being parts per 100, like a percentage, this is parts per million. Okay? Now, I'm going to explain where you would use the two as we go through these different checking for understanding questions. Okay, so the first one, it says the average aquarium is 3% salt. The average aquarium is 3% salt solution. If a marine biologist had measured the aquarium to be 20% salt solution, how would you qualitatively describe this solution? So merely based observation, how could you express this qualitatively? Okay, and you could say that, well, that would mean that the 20% salt solution aquarium is more concentrated. Okay, you're just saying it's more concentrated. That's qualitatively describing it. Okay, something quantitative, remember, is an actual measurement. It can be measured. But you could say that the 20% versus the 3%, the 20% is more concentrated. Done. That's a qualitative. That's an observation. Okay. All right. Number 2. If given 1 million Skittles, how many Skittles would represent 50%? Okay, well, if you had 1,000,000 Skittles, okay, and I can do this, I do it right here, do it right here, number 2. Okay, so if I had 1,000,000 Skittles, how much would represent 50%? And if you said 500,000, you are correct. Okay, I know these are kind of simple problems, but it's going to help us understand the bigger picture. Trust me. All right, gonna break it down for you first. And then it says a cranberry juice bottle contains 50% juice. Another cranberry juice contains 100 ppm juice. Which juice is more concentrated? Okay, well, let's take a look. And I can do number 3 here as well. Okay. All right, let's take a look at the 50% juice. Okay, 50% juice would just be 50 over 100, right? That's 0.15 multiplied by 100 is 50%. Okay. Now, let's try to get 100 ppm in a percentage so we can compare the two, right? We need to compare them in their same amount. Okay, so 100 parts per million would just mean that it's 100 per a million. That's what it means. Okay, so if you were to do this, boom, 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 this is 1 over 1,000. Okay, which one do you think is more concentrated, the 50% or the 1 over 1,000? Okay, definitely the 50%. Okay. All right. So hopefully that made sense. Remember, going back, the difference between these two is just you're multiplying by 10 to the 6 versus 100. Percentage is multiplied by 100. ppm is multiplied by 10 to the 6, which would be 1,000,000. That's it. No difference. And remember, there's percent by volume or percent by mass. And let me erase this real quick. Okay. Now, instead of this saying mass of solute, this could be volume. Okay, or volume. Same idea though, same calculations, just for 2 liquids. Because you can actually dissolve liquids into each other just as you can dissolve solids into liquids. So we can compare their dissolution in a formula and their concentration in a formula the same exact way. That's it. All right. Okay, let's move on. Let me erase this. Okay, now, this is an important slide. When do we use each? So if we have large amounts of solutes, we use percentage. Small amounts, we use ppm, or when the proportions are small. Okay, all right. Now, here's some conversions if you guys forgot. Oop, right here. Okay, we got micro, million, kilo. You need to be familiar with those. You should already be familiar, but just in case you're not. Now, let's go over these checking for understanding questions, because I know some of you had questions on this. Okay, so number 1, it says 35 grams of sugar are dissolved in 100 grams of solution. What is the percent by mass of sugar? Okay, well, how do we find percent by mass? Going back. Here we go. Okay. Percentage is the mass of the solute over the mass of the solution times 100. Let's do it. So what is our solute? Sugar's our solute because it's being dissolved. And it says in 100 grams of solution. So all this is 35 divided by 100. We'll get a value, then multiply that value by 100 to get your percentage. So 35 divided by 100 is 0.35. Multiplied by 100 gives us 35%. So what is the percent by mass of sugar? 35%. Done. All right. What is the percent by volume of ethanol in a solution that contains 40 mils of ethanol dissolved in 120 mils of water? All right, remember, we're still using this same exact equation, but now we're doing percent by volume. Okay, so rather than the mass of the solute or the mass of the solution, we're using the volume because it's a liquid into a liquid. That's it. Okay, so same exact thing. Let's do this. Okay, it says what is the percent? So we're trying to solve for the percent. let's set up our equation. We have 40 mils of ethanol dissolved in 120 mils of water. So if the ethanol is being dissolved, that is the solute. So that's our numerator. So 40 mils on top. Now, remember the denominator is the entire solution. Okay, the entire solution is not 120. That's the amount of water. The entire solution would be the 120 plus the 40. So 120 plus the 40, plus the 40. So this would actually be 40 divided by 160. Notice over here, I gave you the grams of solution. Over here, I give you milliliters of water, which is the solvent. And remember, the solution is a solvent plus the solute. So we have 40 divided by 160. Okay. If you guys do that, I'll give you time to do it on your calculator if you can't do it in your head. And remember, always you've got to multiply by 100. You come out with 0.25 multiplied by 100. This is 25%. Okay, 25%. It's a 25% solution of ethanol. Okay? And then the last one, number 3. It says, what is the concentration of O2, that's gas, so O2 gas, in parts per million in a solution that contains 0.008 grams of O2 gas dissolved in 1,000 grams of H2O. So we're just trying to find the concentration. Remember, parts per million, same idea. Mass of the solute over mass of solution, but instead of multiplying by 100, we're multiplying by 10 to the 6th, or a million. Okay, so let's set this up. So we have 0.008 grams divided by, okay, now this is 100 grams of H2O. Remember, we need the entire solution. So that would be 1,000, whoops, why does that? 1,000 plus the solute, which is 0.008. So this would be 1,000.008. Because it's the solvent plus the solute to get the solution. And remember, the denominator is the mass of the entire solution. It's a part over the whole. Okay. All right. Oops, too far. Okay. So if we do this, I'm going to do it on my calculator. Okay, 0.008 divided by 1,000. 0.008, we get something 7.9999999. So I'll just keep it at 7.99 times 10 to the negative 6. But guess what? We have to multiply it by a million. So times 10 to the 6, that would mean the 10 to the 6 cancel out. So this is 7.99 ppm. That is the concentration of that particular solution. Okay, so we did the mass over the entire solution. We got a value. Since we're doing ppm, we had to multiply it by 10 to the 6, and we get our parts per million. Okay? All right, moving on. We have another ppm question. I'll just kind of go through this quickly since we just went through one. Okay, in this particular question, it says, a pond was found to contain 50 grams of mercury. The estimated mass of the pond is 200 kilograms. What is the concentration of mercury in ppm? Okay, now, look at here. Look at my solution right here. We have the solute. Here it says the pond is 200. So this is the entire solution. Okay, now, notice that this is in kilograms and this is in grams. Make sure they are the same unit in order to solve. So here I've put them both into grams. So this is 50 grams over 200,000 grams because all we have to do is multiply by 1,000, 200 kilograms. Let me do this a little bit neater. To convert 200 kilograms into grams, there exists Mr. Mitchell's making a goof. 1 kilogram there exists 1,000 grams. Kilograms cancel off. So you do 200 times 1,000, which gives you 200,000. Okay, so it's 50 over 200,000 times a million, and you get 250 ppm. That is the concentration of the solution. 250 ppm. All right, and then this last slide is more molarity practice for you guys, and I've broken down each one. Okay, now, the biggest thing here is sometimes I can give you grams of a particular solute, and then you just need to get into moles. Okay, that would be the only, like, crazy step in this. Or I could give you something in milliliters, and you need to get it into liters. Well, the reason why that is because the molarity formula is moles of solute over liters of solution. So you have to be in moles and you have to be in liters, as previously stated in the simulation video. Okay, molarity is the most common. Us chemists, we like using this. Okay, we can go through a couple of these. I can go through my solutions, but they're pretty self-explanatory how I went through them. I was pretty explicit here in my solution key. So the first one is 1,000 milliliter IV solution contains 90 grams of glucose. That's C6H12O6. What is the molarity of this solution? Okay, so we need the moles of our solute, and then we need the entire solution. Okay, well, in this particular case, the 90 grams of glucose, that is our solute. So we need to get that 90 grams into moles. Now, in order to do that, we go to the periodic table and we set up a unit conversion. In glucose, C6H12O6, there exists 180 grams. So we put grams on the bottom, grams cross off. Oops. So we're left with moles. So 90 divided by 180 is 0.5. So we got our amount of moles of glucose. Now, notice how the entire solution, 100 mils of IV solution, okay, we need to get that milliliters into liters because that's what the formula says. It's got to be in liters. All right, so that's what I've done here, just a simple unit conversion. We know we're working with 0.1 liters, so we do 0.5 divided by 0.1, and this is equal to a 5 molar solution. A 5 molar solution, that's that big M. Okay, and then here we got the practice. As you can see, here's the solution key, here's the answer. These aren't anything crazy, okay? Number 2, I find the moles first, and then I just convert it into grams by multiplying by the molar mass. That's it. The molar mass of NaOH is 40 grams. Since we're working with 2 moles, 2 times 40 is 80 grams. Okay, and then this one here is pretty easy. All I've done is convert 9 grams of H2O into moles, and then convert 1,000 mils into liters, and then solve and get a 0.5 molar solution. Okay, all right, guys. Hopefully this helped, and let me know if you have any other questions. Good luck on your quiz tomorrow. Remember, the window is 10 a.m. to 12 p.m., and that's during kind of the official HBHS science window. All right, see you guys.